All right, here we are. We're continuing on in chapter 2, diving into some real good, honest to goodness algebra. It's at the top of your notes then, look up there and make sure you have 2-8, and we're solving two-step equations today. So we're taking some of yesterday's stuff and now adding another level of complexity. So today's learning target is I can solve two-step equations and I'm going to add on here with rational numbers. Okay. And you can use the calculators now, okay, because I'm really testing your process and not the computation part. Okay. It's still always good to have an idea or an estimate in your head of what you think it should be close to. We'll go from there. All right. Now, what I want you to do is think back. Have you ever had somebody pull these like number puzzles, something like this one? And it says, I'm thinking of a number, and when I multiply it by 5 and subtract 11, I end up with 24. What's my number? Okay. Do you know how they really, really do that? Well, first of all, pause the video, think about this for a second, and see if you've come up with the number. All right, did you figure it out? You multiply it by 5, take away 11, you end up with 24. What's your number? Did you get 7? Because what you had to do was start with your ending result. Instead of subtracting 11, you went and added 11. Okay, so you're undoing. That gives you 35. And then you're thinking, what number, when I multiply it by 5, do I end up with 35? Boom, there you go. This is the exact same process you're using when you're solving algebraic equations. So, first, remember these rules. I pound these into your head, okay? Find the variable. Get the variable alone. You isolate it by undoing, and then you check your answer. Now, when we have more than one step here with the undo, it's important that we make sure we do the order correctly. Most of the time, as you work backwards, what you're going to do is undo any adding or subtracting first, because that's further away from your variable, and then undo the multiplying and dividing. Tomorrow we'll get into some that actually are the exceptions to this, but most of the ones you'll see today work this way. And now it is super important to check. I'll save the watch out for tomorrow, okay? So jot down this first one. There's only about 3 examples today. 8y plus 12 equals 36. Put in your fairness bar here, okay? Whatever you do to one side, you have to do to the other. Here's my variable. I'm multiplying by 8 and then I add. So we need to undo and in the reverse order. That means you're going to deal with 12 first. So we're going to subtract it and be fair and do the same thing on both sides. Disappears. On this side, we have 24. Now, one more step to go, okay? But you have to make sure you show me on both sides. Divide by 8, divide by 8. 8 divided by 8 is 1. Show me that. And you end up with 3. Now, you're tempted to say, fine and dandy, I'm done. But you have a calculator right there in front of you. And I want you to go and check this. 8 times 3 plus 12. Boom. You better get 36 when you check it off. Good. Next, try this one. Ooh, look at this stuff. Thank goodness for the calculator. Negative 3 1/10 k minus 12 5/10 equals 77 71/100. Well, what kind of nastiness is this? Focus on your process. There's my variable, that k. I will need to, first of all, take care of counteracting the minus 12 5/10. Let's add it. Because when I have this negative one and the positive one, they're going to wipe out and add to 0 because they're exact opposites. But you have to be fair and do the same thing over here. Now, you've got a calculator, or you can do it by hand. Negative 3 1/10 k now equals, Let's see, 1, 2. If you've got a calculator, you're going faster, I would hope. 90 and 21/100ths. Okay, last thing we need to do is divide, and specifically by -3 1/10. By -3 1/10. I get K equals, let's see, I better check this on mine because this one I'm not so quick with. 90 and 21/100ths divided by -3.1, I get -29 and 1/10. Now, how can I be absolutely certain that's correct? You need to grab that calculator and check it. Here's my original problem. -3 and 1/10 times whatever K is, which I'm saying is -29 and 1/10, and then I'm going to subtract 12.5 more. Plug all this in, and you should end up with 77 and 71/100ths. Whew, it worked. All right, oops, there was one more here somewhere, I thought. We better make one up. Here we go. m/4 minus, or let's say plus 3.5 equals, I don't know, what, 11? Okay, let's do that. Here's my variable, okay? The first thing we need to do is counteract 3.5. You have to be fair and do the same thing over there. Those are opposites, they go to 0. So I'm still left with m divided by 4. On this side, if you crank this out, you should get 7.5. Alrighty, good to go. Here's m. I'm dividing. The way we counteract this is we multiply. And when you multiply by 4, this 4 divides out this 4 in the denominator, and that's why we're left with m, 1m, yay. And this should give you exactly 30. Now, are you certain that's correct? Grab your calculator and perform your check. Take 30 divided by 4, add 3.5 more. Let's see what happens. When you do this, you should get about 7.5. You add that, you get 11. Boom, you're done. All right. These ones, you can use your calculator to help you perform the operations, but you have to show me the work on both sides, every step. Okay. On your mark, get set, go. Your assignment is in your big packet, and you're doing pages 17 and 18. Show your work. Good luck, and may the force be with you.